So let's start this concept. Weight of four-door sedan versus number of gallons used to drive 150 miles. I need to find out if there's a relationship between the weight of the car and the number of gallons used to drive 150 miles. Okay, so these are the data we have. The weight in thousands of pounds, weight of car, versus number of gallon used. Okay, and this is in gallons. First thing we do, we know by now how to do count. It is count, this code, and you go all the way from here to the lowest, and then close it, and that will give you 12. Same thing for the other one. And average, do this, and then let's say you want to find the average of this one all the way down, and that is 6.07, and you could do the digits adjustment, and then the last one is standard deviation. Do this one, and the same numbers all the way to 6.9, and then you close it, and that's the standard deviation. Of course, you have to do the digits. Okay, 0.75. At the end, we will do some code that we did not study before, which is correlation. Correlation using Excel. Okay, this one. So we'll do the correlation between the weight of the car, comma, and then the number of gallons used all the way down, and then you close it. And that is, of course, you have to do it 2 digits up to the decimal, 0.91. Now, since we got these parameters, we will cancel this because we have the answers over there. Okay, now we need to do a graph. So what we need to do graph, we need to do a graph between this weight of in thousands of pounds versus number of gallons, and then we'll do the correlation later on. So insert, scatter, and then we'll have the data like this. We will cancel this. We don't need the series to be put like that, and then we're going to click on the graph, and you see the chart tools. You come here, you push layout, and then axis title, the horizontal. So you could have it here, axis title, and then we do the same thing, axis title and primary vertical. We make it rotated. So now you can see the y-axis here too. So we should put the title of the axis. This is weight in thousands of pounds. And then you come here to the number of gallons used. Okay, so now we are done from putting the x-axis title and the y-axis title. Let's make the graph a little bit better. So we can see that the y-axis, the lowest is 2, so we're going to make the lowest and fix it at 2. You don't want to make it 0. You want to make the graph looks nicer. So now like this, and you can see that the y-axis, the lowest is almost 5. So we're going to take the y-axis minimum not like that. You click in the y-axis, and then the fixed is 5. Now the graph look nicer. So we click on the points, and then right click on the points. You can see add trend lines, and then you leave it linear, and display equation, display R square value on chart, and that is the equation of the fit. What is Y? Y is number of gallons used. And what is X? X is weight in thousands of pounds. 1.0762 times the weight of thousands of pounds plus 2.7483 equal number of gallons. So if I give you another number away from this table, and if I tell you, okay, if I have the weight of a new car in 1,000 pounds, let's say 6,000 pound car, you multiply 6,000 times 1.0762 plus 2.7483, it will give you number of gallons that will be used to drive 150 miles. Okay, so this is the best fit, and R square 0.83 is not bad. It's a very good fit. Now let's do some statistical regression for the data that we have. So you go to data, data analysis, and regression. You say okay. So let's see what is the Y input. The Y input is number of gallons. So you go all the way to 6.9, and that is the Y input. What is the input X? The input X is the weight in thousands of pounds, all the way here, and you stop. Labels, of course, we don't have labels here because we just put the numbers. Confidence interval, and this is we're going to use this value. Okay, let's just use this value as for this cell. Let's go down here. Okay, and then residual, standardized residual, and I think that's it. You click. Remember, you got here the correlation 0.91 from the other code. We find it here, multiple R correlation. R squared 0.826 or 0.83, which is what we have in this graph, 0.826 or 0.83. And you could find the other adjusted R squared. These are different statistical parameters, standard error and observation. We have 12 data points. And you can see here the ANOVA test that we'll be discussing in the next concepts. And the equation is, as we mentioned in the graph, 2.748 is the intercept, and the multiplication of the variable is 1.076. You have the standard error of each, T statistics, the B value, and you can see the B value is very significant, extremely significant. And of course, it will give you other statistic variables like upper 95%, lower 95%, and also the intervals between lower and upper of each one of them. So we will stop at this point, and hopefully this is understood. This is a very good concept. Please try to practice.